Alright, so what's the difference between the absolute min and the local min? Absolute min is the smallest function value on the entire function, whereas the local min is the smallest function value when x is near some number c. So it's only in a small neighborhood. So now here they talk about where you have absolute max or mins, local max or mins, or neither. So you have an absolute min at R, you have an absolute max at S, and you have local mins at B and R. You have local maxes at C. You have neither a max nor a min at A or at D. Now here you have an absolute max here at 4. There is no absolute min because this is a hollow circle there. Local max, you got a local max at 1, or yeah, you have a local max at 4, 1, 2, 3, 4 here, and at 6, up here at 6, you don't have one at 1 because that's a hollow circle. Local min, you have a local min at 2, and you have local min at 1, which is actually f of 3, f of 1 equals 3, it's a solid dot there, and f of 5 equals 3 is right there, that's a solid dot there, so that is a local min. So now here they ask you to sketch a graph that is continuous on 1, 5 and has an absolute max at the endpoint 5, has an absolute min at 2, and a local max at 3, local min at 4. That's a very good graph of that. 11a says sketch a function that has a local max at 2 and is differentiable at 2. So it's just a parabola peaking at 2. Local max at 2 is not differentiable, so it has a corner. Has a local max at 2 and is not continuous at 2, so it has a break. Alright, sketch function of graph from -1 to 2 that has an absolute max but no absolute min. Well, there's an absolute max there, and for a min, since it goes down forever, it doesn't have a minimum absolute min. Discontinuous has both an absolute max and an absolute min. Well, there's your absolute max, there's your absolute min. In fact, it has a break and it means it's discontinuous. 15, they say sketch it and then identify any absolute or local max min. So this is going down forever, so it doesn't have a minimum, but it does have an absolute maximum at the endpoint. 17, this one has a absolute max at 1. It does not have an absolute min. This one has an absolute min at 0, but no local min and no absolute or local max. This one has an absolute max here at 2. Doesn't have a local max. It doesn't have an absolute or local min since it goes down forever. This one, it has an absolute max at the endpoint 0. But no local max and no mins at all. Alright, now 29, now they're asking you to find critical numbers, so you take the first derivative and set it equal to 0. Take the first derivative, factor it, set each one equal to 0. You're looking where it's equal to 0 or undefined, so you set your numerator equal to 0, denominator equal to 0 as well. So when you take the derivative and you simplify this down, you get to here, and if you set the top equal to 0, you get 0 and 2. When you set the bottom equal to 0, you get nothing because it gives you a negative under the square root for the quadratic formula. This one, when you take the derivative and simplify it down, you get to here, and so each one of these is going to give you a critical value. Now note that the number 1/2 is not part of your, it's not a critical number because it's not part of your original domain. Critical numbers must be a part of the original domain in order for them to be called critical numbers. Now when you take the first derivative here and you bring them together so they have the same common denominator of 4 times the 4th root of t cubed, then you can set the numerator equal to 0 or the denominator equal to 0 and you get 4/9 or 0. This one, when you take the derivative and you bring them together with the same denominator, you can reduce the numerator as best you can and factor. And when you set things equal to 0, you get 0 for the denominator, you get 4, you get 8/7. Those are your 3 different critical values. Take the derivative reduce, bring it together as one big fraction. Now you set each one equal to 0 and you get your critical values. Here you take the derivative, you factor, and you can set each factor equal to 0, and so you get multiples of pi for both answers, actually. Well, this one you get even multiples of pi, and here you get multiples of pi, so ultimately it's just multiples of pi. With this one, when you take the derivative, you get this guy here, and when you factor out an x, you get this here, so x equals 0, or 0 equals 1 plus 2 ln of x, and when you solve that, you get minus 1/2 equals ln of x. Using logs to rewrite it, x is e to the negative 1/2, or 1 over square root of e. Notice your domain is greater than 0, so x equals 0 is not part of your, it's not a critical number here. So you take your derivative, you set it equal to 0, and now they want you to find maxes and mins, so you check each of your critical numbers as well as the endpoints, and you just pick the largest and smallest. So here are the endpoints, and here's the one critical number. They pick the largest and smallest. First derivative, set equal to 0, find your critical numbers, check each critical number as well as the endpoints, and they pick the largest for absolute max, smallest for absolute min. First derivative, reduce, set it equal to 0, and you get these numbers, but these guys are not in your domain or in your interval, so they're out. And you check the endpoints as well as the one critical number you found, and you pick the largest and smallest. This one, you take the derivative, solve it for t, you end up with t equals plus or minus 1 over 3 root 3. Notice the first derivative does not exist when t equals 0, so that's a possible critical number, as well as these two. So you check your endpoints of minus 1 and 4, you check your two critical numbers as well as 0, and you pick the absolute min and absolute max, max and min. I showed all the work here, but it's up to you if you want to actually do that kind of work. It took a while to get that. When you take the derivative, okay, factor, set each factor equal to 0, you get nothing here, but you get pi over 6 here. So you get one critical number to check and two endpoints to check, and you pick the absolute max and min. So here you take the first derivative, write it as one fraction, set the numerator equal to 0, denominator equal to 0, and you get e to the 1/2 power. But notice when you get x equals 0, that's not in your interval from 1/2 to 4, so it's not one of your critical numbers. So you take the endpoints of 1/2 and 4, as well as the one critical number you had, and you pick the largest and smallest. 65, you take the first derivative and you get this guy here, and you set the numerator equals 0, denominator equals 0. Denominator doesn't give you anything. Numerator gives you one critical number. So you try each endpoint as well as the one critical number and pick the largest and smallest. So here they want to know what is the maximum blood alcohol content during the first 3 hours. So here's your formula. Take the derivative, set it equal to 0, set it equal to 0, and you solve, and you end up getting t equals this number, which is roughly 0.35689, or 500 over 1401. And so now you check each endpoint as well as the one critical number you got, and you find that you have a maximum blood alcohol content at this number, or 0.36 hours after the first drink. Okay, blood in the bloodstream, what's the maximum concentration of the antibiotic during the first 12 hours? So you take the first derivative, set it equal to 0, and solve to find your critical numbers. Takes a little bit of work here, and you finally find t equals this, which is a little over, a little bit past the second hour. So you plug in the two endpoints as well as the one critical number, and the place where you get a maximum concentration is at that critical number.